Okay. Okay, so those are kind of some vocabulary to be familiar with as we move forward. Okay, another thing which we mentioned before, but just to be familiar with, okay, is that the periodic table you're used to looking at, like the one on paper, the one on the wall, actually like takes a group out of order. And so this is really what the periodic table looks like if you put everything in order. Because this entire F block down here, notice 57, 89, actually belong right here. But they've kind of like cut them and put them below. To be honest, I've yet to find like exactly why we don't do it like this on a paper, besides the fact it fits better that way, like on an 8 by 11 piece of paper. But just so you know, like, so when we're looking at rings, right, all of these are 6 and all of those are 7, like we kind of addressed before. Okay? All right, another pattern on the periodic table is divided by that staircase, where everything on the left of that staircase is a metal, everything on the right is a non-metal, and then you have the metalloids that make up the staircase. So once again, mine's taped off over here, so you don't really have to memorize where it is. Just know everything on the left is a metal, minus who's the adopted one? Yeah, notice hydrogen hangs out with the metals, but isn't an actual metal. Which can maybe help because it is a gas, right? That's why it's red up here. So that can kind of help as well. Okay? All right, another pattern are whether they're a solid, a liquid, or a gas, which once again is also shown on mine. So these things you don't have to memorize, like what they are, just what they're telling us. So everything on mine that has a black letter, once again up there, is a solid at room temperature. Everything that is blue is a liquid, and everything that is red is a gas. So as you can see, most elements naturally are solids. And then we covered this before, but then you have the different SPD and F sections. Okay? All right, so Coulomb's law, okay, as we learned last time, helps us understand how the trends work on the periodic table. It applies to that relationship between the positive protons and the negative electrons. And then like we just mentioned in our warm-up, it's all about the magnitude and the distance. Right? If magnitude goes up, attraction goes up. If distance decreases, attraction goes up. Okay? So fill those in, and then we're going to do a little piece to yourself, and then we'll share in that box right below. So based on what we learned last time with Coulombic attraction, what this question says, I'll put it up here. Oh, maybe it doesn't show you the question. Oh, there it is. Okay, what can you predict about the periodic table based on what you already know and what you have already learned about Coulomb's law? Or if I were to rephrase the question, can you tell me which element on the whole periodic table would have the most attraction and which one would have the least? So think to yourself, no talking, and write your own answer in that box for your brain. Right? So you can either answer the question as it's worded or write down 2 elements and say, of all of them, this one would have the most attraction and this one would have the least. Let's see if we can kind of put a pattern to the periodic table. So I'll give you 2 minutes. Think to yourself and put something in that box. Once again, to show me you're engaged, just try, even if it's completely wrong. I'd rather have you be wrong and try than not try at all. So put something in that box, either answering that question, or you can tell me this element would have the most Coulombic forces of them all. Or I know this one would have the least. to your table buddy and tell them what you wrote. Ready, go.
I know. That's less engagement.
I said no, but like, what could like
Don't deny it.
Next week.
because on the chart, like you can look at like if it just has more protons then it has more subtraction. And so
Okay, now, as I was walking around, some of you did pick the wrong thing. But when you make a mistake, there's value once again in recognizing why you chose that, because I would wager that you had parts of it because of what you picked that were correct and you just maybe missed, particularly with coulombic, that we have to look at two factors. So what are the two factors you look at when a coulombic force? Distance. What kind of distance increases force? Smaller. So that should tell us that if we want something with a ton of coulombic attraction, it needs to be small because the electrons need to be close to it, right? So that tells us it should be something at the top of the periodic table, okay? Now what's the second factor to look at? Proton number. So if I go to the very top, you have two options, hydrogen and helium, which a lot of you pick hydrogen, which means you were almost there, but the answer would be helium has the most because small and more protons. Okay, so you gotta look at both factors. So helium has the most coulombic force on the whole periodic table. Which one then has the least?
Francium?
Thanks, Caleb. Yep, francium. Because opposite end. It's big and has less protons. So this has the least coulombic attraction, and then as I go diagonally that way, it gets stronger and stronger and stronger. Okay, so keep in mind as we keep going, you gotta think about both parts. Don't just think about distance, but also think about magnitude. And also don't only think about magnitude, also think about distance. Okay? Okay, so this is what we just mentioned. So the vertical pattern is that as you go down, coulombic attraction decreases because distance goes up. Right? If you have more rings, it doesn't matter you have more protons. Those valence electrons are just too far away. And by the way, when we're talking about coulombic forces, we're focused primarily really on just the valence electron. So this force right here. Okay, how much force does it hold? And obviously the smaller something is, the closer the distance, and so the tighter the hold. Okay? Horizontally, we see that as you go across, since proton number is going up, we're going to have a greater attraction between them. So attraction increases as we go across to the right. Neon holds a lot tighter onto its valence electrons than chlorine does, or any of the others. And lithium kind of barely holds onto it and gives it away quite easily. Okay, there? Okay, we're good. Okay, so once again, like we mentioned, we have this diagonal pattern. There's kind of a little, kind of rhymes type thing to help you remember. Up and to the right are held more tight. So if I go up and to the right, the electrons are held tight. Low and to the left, held more loose. That's the one that doesn't quite rhyme as well. But if you have a better idea for us, that's the best we can come up with. Okay? There's kind of the pattern of like which ones hold on tightly, which ones hold on loosely. Okay? Any follow-up questions on understanding what coulombic forces are? All right, we're going to do a little activity now to learn about two more patterns on the periodic table and being able to predict what their pattern is in terms of, oh, it increases this way or it decreases going down. Okay, to do this, what we're going to be doing is we're actually going to make a 3D model of the trend to try to bring it to life of what's going on. Okay, so here's how it's going to work. You're going to work, so front row, you're going to be in a group of 4 with the people behind you. And then same thing, third row, and those that will fix our holes over there. So you have 4. Does that make sense who you're going to work with? Okay, so these are the supplies that you should have. The front row people have a bag containing a lot of straws that are cut to various lengths, a small periodic table, and a teeny tiny, this is called a well plate. Okay, what you're going to be doing here is you'll place your well plate on top of your periodic table so that the little circles line up with the elements. Okay, you'll then be placing straws in the hole that correspond to that element's property. And in the end, you'll then have this 3D model that's height of the straws will tell you, oh, it's increasing or it's decreasing based on what the straws are doing. Okay? So what you'll be doing as a group, now you're in a group of 4 to help make this go quickly. So figure out how you can work as a team to get this done as fast as you can, because then you can get the questions done. Okay? This right here on your paper, so you have a pink or a yellow one depending on what trend you're doing. So every other is like doing a different trend. Okay? The trend right here, so the yellow one's for atomic radius, which corresponds to the size of the atom. Okay, measuring from the middle of the atom to the outside edge, just like the radius of a circle. Okay, on your paper is listed the elements already in order by size. So helium has the smallest radius, rubidium has the biggest of the ones that we're graphing. Okay, first step is you need to, as a group, once again, because it'll make it a lot faster, you need to line up your straws from shortest to tallest, okay, so that you can then put them in accordingly. Okay, you'll line them up from shortest to tallest. Then, this little strip right here that you have is going to be your labels. Okay, so the group that you're paired up with on their table has tape and scissors. Okay, so if you don't have this, you should have tape and scissors in front of you. Or let me know if you're missing that. Everyone good? Okay, so what you'll do is once I line them up smallest to tallest, I'll then cut the helium label and I'll tape that onto which straw? The shortest, because according to the data, helium should be the shortest. So then you have to put the label on the matching straw and then I can place it in my periodic table. Questions on that? What I would recommend for like putting it on the straw, right, so you'll cut it, and then just wrap the paper around and then just kind of like seal it on with tape. That makes sense, that should be the easiest. So, okay, you guys have the responsibility to figure out how you want to divide up the work to make it go as fast as you can. Once you have your model made, then you can start working on the questions that are in your packet. Okay? All right, let me know if you have any more questions as you're working. I'll figure out that to help. Let's figure out what to do with our missing teams here. Okay, so Austin here. Great. So you guys, you turn around because you're with them as sports. No, you're good. And then, will you come over here with Austin and then you guys can be four of them? It's just easier to be like this versus the line. Okay, does everyone have 4 now? Oh, lovely.